Now, just like you have a pH scale, which shows the concentration of H plus ions in solution, we also have a POH scale. And the POH scale will show the OH minus concentration in solution. So just like pH is equal to minus log of concentration of H plus, POH is equal to minus log of concentration of OH minus, and from this OH minus, from POH we can get concentration of OH minus, which will be 10 to the power of minus POH. Now pH and POH, they are inverse scales of each other. Just like pH is a scale which shows acidity of a solution, that is concentration of H plus in a solution, POH is a scale that shows concentration of OH minus in a solution, and it's inverse to the pH scale. So pH goes from 0 to 14, and at 0 we have very high acidity, 14 we have high basicity. POH also goes from 0 to 14, but 14 has high acidity and 0 has high alkalinity. And both will have 7 as neutral pH. Now, because it is a logarithm scale, that tenfold change is also going to apply. For example, if we have a pH that changes from 1 to 3, the difference is 2. Therefore, there's going to be a 10 to the power of 2 100-fold change in concentration of H plus. Similarly, if the POH changes from 7 to 14, there's going to be a change of 7. Therefore, 10 to the power of 7-fold change in OH minus ion. So that 10-fold change also applies for the POH scale. Now, from the expression that we have just seen, where H plus times OH minus is equal to kW, that is 10 to the power of minus 14 at 25 degrees Celsius, that is 298 K. Now, if we take the expressions that can be used to replace H plus. Now, H plus is also equal to 10 to the power of minus pH. And OH minus is also equal to 10 to the power of minus POH. So we can rewrite the expression to have this. Now, if we insert log on both sides, the 10 is going to cancel out. So we'll end up with, so let's apply log on both sides. So this is going to get eliminated. So we'll end up with minus pH minus POH is equal to minus 14. Now, because we have all these negatives, we can eliminate them. So let's take out the negatives. And we'll end up with this. Negative cancels out, so we end up with the expression pH plus POH is equal to 14, and this applies at 298 K only. So if I tell you that the pH of a solution is 2, from this you can deduce that the POH is 14 minus 2, that's going to be 12. Now, from this pH value, you can easily calculate H plus concentration, which will be 10 to the power minus 2. And from this POH value, you can easily calculate OH concentration. That is going to be 10 to the power of minus 12. But this applies only at 298 K. Now, if you want to have an expression that can be applied at any temperature, we'll have to consider pKW. Now, pKW can also be calculated by applying logarithm. So, minus log of kW is going to give you pKW. And kW can also be calculated by 10 to the power of minus pkW. So it's the same relation, same logarithm relationship. Now, once we have calculated pkW, we can have the same workout as this. Now, you don't need to know the derivation. You just need to know this expression. And if we derive it the same way, we can have the expression pH plus pOH is equal to pkW, and this applies at any temperature, because at different temperature we'll have different we'll have different kW values, so we'll have different pkW values. Now let's see how we can apply pH and pOH. So if we have a lemon juice of pH 2.9, so from the pH I can find H plus concentration, it's 10 to the power of minus pH. From the pH I can get the pOH, which is going to be at 25 degrees Celsius, so 14 minus 2.9, so 11.1, and then I can find the OH minus concentration, so 10 to the power of minus 11.9. Of course, you're going to calculate the value, don't just leave it like that. So 7.94 times 10 to the power of minus 12. Here I have 1.26 times 10 to the power of minus 3. If you do number 2 and number 3 correctly, you should get these answers. So try them out and then check your answers.